This video will cover the alkylation of enamines. An enamine is an amine next to an alkene. The lone pair of electrons on nitrogen give this structure a resonance structure, which explains the reactivity of the enamine molecule. The alkene carbon furthest from the nitrogen is nucleophilic. This is the carbon that has the negative charge in the resonance contributor. Because of this, enamines are nucleophilic at the carbon of the alkene furthest from the amine. Enamines react in a similar manner to enolate ions, in that they result in the substitution of a proton with another group through attack on an electrophile. The lone pair of electrons on the nitrogen come down, allowing the alkene to attack the electrophile, forming a new carbon-carbon bond. The product of the attack of an enamine on an electrophile is an iminium ion. Hydrolysis of the iminium ion results in the original ketone or aldehyde. Enamines are synthesized from ketones or aldehydes through the addition of a secondary amine under acidic conditions. Notice then that the overall reaction results in an alpha substitution to the original ketone or aldehyde. Therefore, this reaction is very similar to the alkylation of enolate ions. However, alkylation of enamines occurs under much more mild conditions. Additionally, because it doesn't require treatment with LDA, this synthesis works for aldehydes as well as ketones. The mechanism for the alkylation of an enamine is shown here. The hydrolysis of the iminium ion, the last step shown here, has been discussed in a previous video. Now we'll talk about how an enamine is synthesized from a ketone or an aldehyde. As mentioned previously, an enamine is synthesized from a ketone or an aldehyde and a secondary amine. The synthesis is carried out in the presence of an acid catalyst. In the first step of the mechanism, the carbonyl, the electrophile is protonated, making it a stronger electrophile. This intermediate has a carbocation resonance structure. In the next step, the amine attacks the improved electrophile, producing a tetrahedral intermediate. Next, another molecule of amine deprotonates to produce the neutral intermediate. The hydroxyl group is then protonated. This converts the hydroxyl group to water, making it a good leaving group. It then leaves to produce a resonance-stabilized carbocation. In order to relieve the positive formal charge, a proton must be removed from this molecule, and the proton must be taken adjacent to the positive charge. Because the nitrogen has no protons, the proton that is abstracted is attached to one of the carbons. Abstraction of this proton by water relieves the formal charge on nitrogen to produce the enamine. Enamines are useful synthetic intermediates for alkylation at the alpha position to a carbonyl. They also make good nucleophiles for acylation reactions. An acylation reaction is when a nucleophile attacks a carbonyl carbon, such as the carbonyl carbon of an acid chloride that has a good leaving group. For example, the reaction between this enamine and this acid chloride. The lone pairs of nitrogen come down to allow the alkene to attack, forming a tetrahedral intermediate. The carbonyl can then reform, kicking off the chloride ion. The enamine is synthesized from the ketone and a secondary amine. And the iminium ion that is formed following alpha substitution can be hydrolyzed under acidic conditions to produce the original starting ketone. With the addition of the acyl group at the alpha position, this diketone product results from the addition of the acyl group to the alpha position of the original ketone.